This is Geometry Lesson 78, the volume of a sphere. We knew the time was coming that my notebook was running out of paper, so I'm having to adapt, and we're going to be on pages 158 and 159, so I'm just adding notebook paper to it. It actually is a little bit easier for me because I can just write with the one page in front of me, but I'm on page 158, and we said it was lesson 78. Volume of a sphere. Volume of a sphere. Now, a sphere is just a fancy name for a ball. That's exactly what we're doing. And I don't have a geometer, and I just happened to realize there was a bottle cap sitting here. So I'm on a water bottle cap, so I'm going to try to use that as my picture. If you've got something handy, if you want to stop and go grab one, this is probably a good size to it's a pretty easy figure to draw because we're going to, I don't have a center finder, so I'm just going to estimate it. And what you want to do is just instead of it just looks like a flat circle, I'm going to kind of dot the back of it, and then I'm going to make the solid front. It kind of looks like an eyeball, but it kind of puts a little depth to it to where this would be the radius. Now, you're using the biggest part, the biggest circumference of the ball, and this circle where you slice through the ball in the middle of it is called a great circle. So you're going to, which is just simply means the biggest circle in it. If you slice it, you're going to have little circles, and then you have the biggest circle in the middle. And the volume, how much it will hold, is pretty easy. It's 4/3 pi r cubed. Okay, so let's try a couple of examples. It may not take more than one page as we're working on it. We'll do one with a diameter and one with a radius. So I like that picture. That works pretty well. I'll draw my circle again. I could have used that one, but I'll just go ahead. This time we'll give the radius. And like I said, if you want to draw it to make it look like a ball, gives a little bit of depth. Sometimes if you want to shade that great circle as you're doing it. So we're going to let the radius be, let's let it be 12 inches. So the volume will be equal to 4/3 times pi, and then r cubed. It's going to be a big number because you're going to be cubing 12. So I've got volume equals 4/3 times pi. Now 12 cubed, I believe on the whatever calculator you're using, there should be different ways of raising powers. On the graphing calculator, it's the little house top. I'm not sure whether we've used that. We've used squared, but this is a case where you want to multiply it. And if you don't have a key like that, you'll just have to do 12 times 12 times 12. That's what you're multiplying. But I can do 12 raised to the third and enter, and it gives me 1,728. So if you have to do it 12 times 12 times 12, that's okay. Still get the same answer. So as I punch that, then I've got, and multiplying 12 inches 3 times. So I've got inches, 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 which is cubic inches. So I'm going to just type it like it's given. Probably the easiest is just to type the top, just come all the way straight across, making those ones under them, and then just do 4 times pi, if you're not using a pi key, 3.14159, times 1728 divided by 3. And I believe it says round to the nearest hundredths, which is 2 decimal places. The 9's going to make the 22 round to 23. So I'll have 7,238.23 cubic inches. Now, if you type it like it's given here, if you type 4 divided by 3 times pi times, and then you can do the 1728. It'll give you the same answer. So it doesn't matter whether you, I just think it's probably quicker just to go straight across and then divide by 3. But if you divide by the 3 at the beginning, 4 divided by 3 times this, it'll still give you the same thing. Let's do a second one. Number 2. So I'll use my little bottle top. Now usually when they give a diameter, they'll put it, like put the number underneath it. So they might say like 30, let's say millimeters. And they'll put it underneath showing that that's the whole thing. Diameter, it won't say this, but the diameter is 30 millimeters. If they just mean the radius, they'll usually just write the number right there on just the part of the radius. And then if we make it look like a sphere, and then if you want to shade the great circle, it does make it look a little bit better. So volume equals 4/3 times pi times, now what's our radius? If our diameter is 30, then 15 cubed. Now you can actually type that all in the problem, but I think most of you would be more comfortable just doing the 15 times 15 times 15, or whichever way, just depending on what calculator you're using. And I got 3,000, so I got 4/3 times pi times 3375. And then again, you can type 4 divided by 3 times pi times this, or you can just multiply and then divide by 3. I think that's the easiest for me to do it. So I'm going to say 4 times pi times 3375. That's the number I had here, divided by 3. And I get a big number, but we were using a big radius, so we've got, you see it, 14,137, 14,137. The 6 is going to make the 6 go to 17, and this will be cubic, what do we use, millimeters.